Jambo. This video is a quick recap of the stuff we covered yesterday, information that we can pull from the periodic table just by knowing an element's position. And eventually later today we'll go fully into electron arrangements, but we'll touch on it right now. If I look at an element like strontium, so I hope you can see where I'm pointing. I'm looking at 38, and here's strontium. The 38 is atomic number. It tells me here in the code or legend there. So that means it has 38 protons. If it's an atom, it's going to have 38 electrons. So that should be fairly straightforward. When I want to know how many layers of electrons it has, I have to see what periods it is in. So 1, 2, 3, 4, 5. Strontium is in the 5th row, so it will have 5 layers of electrons. Of more importance is what group it's in. It is in group 2. That's a Roman numeral 2, so that means it has 2 outer electrons. If I looked at aluminum, I can see aluminum would have 13 protons, an atom would have 13 electrons, and 3s are wild with aluminum because 1, 2, 3, it's in the 3rd row or 3rd period, so it has 3 layers of electrons. It's in group 3, so it will have 3 outer electrons. If I head over here to bromine, and I see, whoa, okay, bromine. Well, 35 protons, 35 electrons. 1, 2, 3, 4, 4th period, so it's going to have 4 layers of electrons, and it will have 7 outer electrons. VII means 7. Now let's go back to strontium. If strontium loses 2 electrons, it goes from 38 to 36. It becomes isoelectronic with krypton. And so strontium, group 2, wants to lose its 2 outer electrons. Metal lose electrons to become stable. Whereas on the other hand, bromine is 1 away from being like krypton with 36, so bromine would like to gain 1. On the back of your periodic table, it tells you this. It says, hey, look, strontium likes to be 2+, 38 protons, 36 electrons. Bromine likes to form a bromide ion, 1-. It likes to gain 1 electron, so it has 35 protons and 36 electrons. So what could you tell me about nitrogen? So when you look at that, I'd like to know how many protons it has, how many electrons it has, how many layers of electrons, and how many outer electrons, and finally, what it will do to become stable. Well, we see nitrogen is in group 2, so it has 2 layers of electrons. It would have 2 in the first, and then 1, 2, 3, 4, 5 in the second, just counting over. And we see it is in group 5, so that makes sense. We see it's to the right of the staircase. That makes it a non-metal. And that means it tends to want to gain electrons to be stable. 5, we add 1, 2, 3. If we do that, it becomes isoelectronic with neon. And hey, it's gained 3 negatives. Therefore, it's N3- when it's an ion. So that's a recap of electron arrangements and electron structures. If I looked at something like, let's say we got chlorine here, and we know it has 17 protons, and let's say that its mass is 35. You don't really want to mess around too much with the masses given on the chart for reasons that will come up later in the course. We're always going to give them to you as integers for a specific isotope. So I'm saying this is going to, I've got a sample of chlorine 35. And I want to know how many neutrons there are. Well, I would go 35 minus 17, and I'd get 18 neutrons. Because I'm supposed to remember that atomic mass comes from protons and neutrons. If this stuff seems foggy to you, you were not paying attention the last 2 years or yesterday. And that means you got to go back through some videos from yesterday and get on top of this stuff.